Okay, so in this segment of our article on the open source development platform, we're going to be discussing controlling I2C devices from Java. This is probably the video worth admission. It's definitely not the most intuitive thing in the world. I2C requires a lot of low-level file manipulation, which from what I've found can only really be done through standard C. A guy named Timothy Wall developed a library called JNA for Java, and the JNA library is extremely important for this development. So a big thanks to Timothy Wall for developing this library. It's what we're going to be using to actually make our calls to the I2C port on the BeagleBone Black. So the first thing we really need to do here is get that library and import it into our project. Now, I do all of my Java application development in Eclipse, so everything you're going to see is going to be done through that IDE. I know some people use NetBeans, but you should be able, if you are familiar with NetBeans or that's your IDE of choice, you should be able to import libraries and things like that. I can't really explain how to do it in NetBeans because it's not what I use. So like I said, I'm going to be using Eclipse. So without further ado, we'll get started on this. So the first thing we need is the JNA library. So for that, we will open up our browser, and we're going to just do a Google search for Java JNA library. And here you'll see that Timothy Wall has a GitHub set up here for the library. So we'll click that link that comes up. And this is his download page for it. He also has some documentation written up here on the Java Native Access library he's developed. He's got a really nice forum here. If you click on mailing list, he was actually kind enough to work with me on getting this set up. I had a couple problems on some calls that I was making, and probably if it wasn't for his suggestions, I probably never would have gotten this done. So once again, big thanks to Timothy Wall on this. So what we need to do is we need to actually download the JNA library, which you can do here. And if you scroll down, you're going to see here under download, looks like he's got version 4.1 up. So what you do is just click this jna.jar here. And this will be the jar file that we will import into our Java project. So now that we've got that, I'm just going to leave it in my downloads directory. We'll go ahead and minimize this, and we'll start up Eclipse here. And I've got a workspace here that I call BeagleBone Black workspace. You can just bring it into whatever you're using as your Java development workspace. So we'll click OK. Okay, and in Eclipse, you can either go to File or just right-click in here and say New Java Project. And we need to give it a name. And I will call this BeagleBone Black I2C Test for the project. And I'm going to let it use Java SE 1.6. You can develop on another version of Java if you want. I'm just going to use 1.6. we'll click finish. Okay, so from here, if we click that, we'll see we've got a source here which is blank, and we've got the JRE system library for Java 1.6. So what we need to do now is we need to pull in that JNA library. So what I like to do is click up here on the root directory, right click, click new, and folder. And we're going to call this folder libs. This is for our external libraries. Okay, now we've got that libs folder, and we're going to pull that jna.jar library into that folder. So the best way I've found to do that is to browse to your downloads folder, grab this jna-4.1.0 jar, and we'll just click and drag that into our libs folder, and we'll just say copy files. Okay, so now we see it here. Now we need to add that to the build. So what we can do is just right click on that that jar, and it'll bring up this menu, and we'll go to build path, add to build path. And now you'll see it created another directory up here called reference to libraries, and it brought in this JNA jar. So you're going to see it twice in here, but that's correct. That's what you want. So then you right click on this jar here, go to build path, and we're going to go to configure build path. And then here what we need to do is go up here to source, click the drop down here, and we're going to say native library location right here. This is under source. Click the drop down for your project. Native library location, we need to click edit, and we're going to say click workspace, and then we'll click this drop down for the libs, or we'll just click libs here, and we'll click OK, and then OK, and OK again. Alright, and that's all you've got to do to bring in the library. So you've got to make sure that you've got it pulled in, added to your build path, and configure the build path, and add that to your native library location. Adding that to your native library location is very important. I won't get too much into why that is in this video, but basically it's just so that whenever you run your Java executable jar that we're going to create here, it knows where to look for that library. If you don't reference it there, you're going to run into some huge problems. So what we'll do now is we'll click on source up here, and we'll right click that. We're going to say new package, and we'll just call this package main. You can call it whatever you want. This is basically just to hold our Java classes. Okay, and then we'll have a package here that says main. Now we'll right click on that main package, go to new, and then we'll create a new Java class. And it should say up here Java class. And then from here what we'll do is we need to check this box for the public main string array. We're going to need that because whenever you run your Java application or your runnable jar, it's going to look for a Java class that contains this main method. So we want to make sure we have that. Of course, you can add additional classes that don't have that main method. But basically what this does is it says, you know, whenever this Java jar runs, run this class first. This is kind of our initialization class. So we'll give it a name here. We can really name it about anything we want. We'll just call it BeagleBone Black Java I2C main. Oh yeah, and you should really always start it with a lowercase letter, I guess, camel case. So we'll just click finish there. You can name it anything you want. It really doesn't make any difference. Alright, so now we've got our main class here. Okay, and what I like to do in a Java application, I don't like to do everything from my main method. I like to create a constructor for this class, which the way we do that is we just say public main. Oh, I'm sorry, public bb underscore java underscore I2C underscore main. Okay, and then up here in our main method we'll just say new just like that, or you could just copy and paste that up there. But basically what this does is the Java jar runs, it starts, it finds this class which has this main public static void main method in it. This runs, calls this constructor, and jumps to here. So this is where we're going to start our code. So from here we'll actually start using the JNA library. So one important thing is we need to tell Java where to look for our JNA library. So what you want to do for that is you want to make sure and tell Java not to look in the Java libraries location on the BeagleBone. We want to tell it, don't look there. We've already got that JNA library in our jar here. So to do that, what we do is we tell Java system dot set property, and then we're going to tell it JNA dot no sys, and we're going to pass that true. So it's telling it, don't look for this on the system. And got a problem there. What is that? System dot set property JNA dot no sys true. And I think before we can actually call that, we need to import the JNA library maybe. So up here we'll say import com.sun.jna.library. And then we'll say import, we'll just do all of our imports now, com.sun.jna.native. And then last thing we need to import is com.sun.jna.platform. And I'm not sure, oh, I'm sorry, yeah, we've got to pass it two strings here. This true has to be in parentheses. True. That's what our problem was. Set property takes two strings, not a string and a boolean. Okay, so we've got that set. We've got everything imported that we need to import. Of course, it's highlighted in yellow because we're not using them yet. Come down here. We need to we need to tell the JNA library the directory of the file we're writing to, which is actually going to be that I2C-1, which we kind of went over in the I2C test portion of this article. So we're going to say we need to give it the absolute directory of that I2C-1 bus file. So we're going to say string file name equals /dev/I2C-1. Okay, that's the file we're going to be writing to. Okay, and then we're going to actually create an instance of the C library on the BeagleBone. The BeagleBone has the C library installed on it, which is what we did whenever we installed the libc, if you remember in the initial configuration. So we need to make reference to that library. Now, in order to do that, basically we have to create an instance of that C library. So down here, we're going to go actually outside of this method, and we're going to go down here and create an instance. We're going to say public interface C library extends library. Okay. And then down here inside these brackets, we're going to say C library instance equals C library native.load library, and we have to pass that platform.isWindows space question mark msvcrt colon C. And then we need to also pass it C library.class. Close some of this stuff out so we can actually see everything here. Yeah, let's see what kind of error we get here. Misplaced constructs. Tell you what, I'm going to copy and paste this code so I don't have to write all of it. And I'll have a link on this article page where you can just download this class as a sample. Get that all on one line. Okay. But basically we're just creating an interface here to that C library. Now we need to reference the methods of this, basically the JNA that we need to access for our particular application here. So the first one is a public integer IOCTL, and that needs to be passed an integer, which is the file directory, an integer, which is the command, and an integer for the argument. And then the next one is public integer open. This is the method we'll call whenever we want to open the file, and we'll pass it a string for the path, which is that string that we wrote earlier, that /deb/I2C-1, and then an integer for flags, which are basically just arguments when opening that file. And then we need another one for closing the file, which is going to be a public integer close, and we just need to pass it a flag, or I'm sorry, a file directory. And then we need a method for write, so we can actually write to that directory, which is going to be a public integer write, and we're going to pass it a file directory. We'll pass it a byte array containing the data that we want to write. We'll call that buffer. And then we need to pass it the length of the byte array, which is being an integer called count. And then to read from the file, we have another one, public integer read, and we're going to pass it integer for file directory, byte array for buffer to contain the data coming back, and then an integer for the count, which is the expected bytes back from the read command. Okay, so that's pretty much all we need for this instance of the C library. So now we'll actually create an instance of it here that we can talk to. So for that, we're going to say we will call it like this: integer file equals C library dot instance dot open, and then we need to pass it a file, which is the file name we just created above there. We'll say file name, and then flags. The flag that we need to create, generally I just reference it up here in this this main, or I'm sorry, outside the main. We actually reference it up here as a global variable: public static integer O underscore RDWR equals 0x, and it's what, 7 zeros, 1, 2, 3, 4, 5, 6, 7, I believe, 2. Let me just double check that. Yeah, that's right. Okay, and that's what we're going to pass it as the flag for opening that file. Okay. So this call right here is actually going to open the I2C file here. So on the next line, we're going to check to see if we were actually able to open that file. To do that, we're going to say if file is less than 0, something went wrong. So we'll say system.out.println failed to open I2C-1 file. Okay? And then we'll just kill the program if that happens, so we'll just say return. Alright, so hopefully everything went well and we were able to open the file and we hit this line. Now we need to create an address. Now you'll remember in our I2C test we did an I2C detect on the command line, and I found that my device was mounted as 21. So what we'll do is we'll create an address for that, and you'll need to enter the byte or the address that your I2C device mounted to the bus as. Like I said, mine was 21, so I'm going to use 21. You use whatever you found. So we'll say integer address equals 0x21. Okay, and then we need to make sure that whenever we're writing out this bus that it knows that we're writing to an I2C slave device. So we're going to create an integer called I2C underscore slave. And we're going to set that equal to 0x0703. And that's pretty much what you're always going to use. You're always going to use 0x0703. I don't know why you wouldn't for any application. Okay, so now we need to make an IOCTL call on this file that we just opened. And a lot of this might sound like gibberish, but just know that this is basically how you initialize communication to that file directory to write to an I2C device. So we're going to say integer IOCTL equals C library dot instance dot IOCTL, and we need to pass that a file directory, which is the file that we created earlier whenever we opened. And then we need to pass it a command, which is going to be I2C slave. And then we need to pass it an argument, which is the address. Okay, So basically we're passing it file, which this integer file was created whenever we opened that directory, this directory. We created this integer, so that's the argument we passed there. Command is I2C slave. That's letting it know that we're writing to an I2C slave device, and the address tells it the address of the device on the bus. So this IOCTL call is basically an initialization of that file so we can actually write to it. And this is basically what I had so much problems with in my initial development. Once I got past this line here, everything was golden. So after we make that call, we're going to make sure everything went okay there. So to do that, what we're going to say is we're going to say if IOCTL, and basically the integer we just created by making that call, is less than 0, then something went wrong. System.out.println, and we'll say IOCTL call failed, and then we'll kill the program. Okay, so hopefully that IOCTL call went through and we make it to this line. Now we're actually ready to start writing to the I2C device. So like I said, on my particular device being a relay controller, the first call I make is to set all of the I/O lines on the I2C chip to outputs. And if you remember from the I2C test, you saw that I passed it 0 for the address and then 0 for the command or the argument. So what we're going to do here is we're going to create a byte array real quick. So we'll say byte array, and we'll just call this byte array buff, short for buffer, equals, we're going to create an array 0, 0, and that's all that we need in that array. Okay, and now we'll actually make the call to write that byte array to our I2C device. So we'll say integer write return, which this is basically going to be the integer that is returned whenever we make a call to write to that I2C bus. C library dot instance dot write, and you'll see we're basically calling all the methods that we defined down there in the C library instance. We're going to pass it file, and then we're going to pass it buffer or buff, sorry, and then the count, which is 2. We created this byte array up here, and it has 2 integers in it. And I messed that up. It's supposed to be buff, and this is supposed to be file. So basically the length of this buffer was 2, so we tell it there's 2 bytes in there. And then after that, we're going to check to make sure everything went okay. So we're going to say if write return, let's see here, does not equal 2, then something went wrong. System.out.println write, oops, failed. Okay, and hopefully that worked. And if that worked, then you've actually are able to control your I2C devices through the BeagleBone Black. I mean, basically, if you make it to here, you're golden. You know, everything's great. So what I'm going to do is I'm going to write a short little while loop here to just turn the relays on my board on and off. These commands are particular to the I2C chip that I'm using, which is a relay board. Of course, at this point, you could just start writing to whatever I2C device you happen to have. But like I said, I'm writing to a relay board. So what I'm going to do is I'm just going to copy and paste in a couple of methods for turning on and off the relays on my board. So outside this main, I'll paste in my methods. which basically I've got a public boolean here called turn on all relays, which I pass a file to, which the file integer I'm passing here is just this file integer we created whenever we opened the port to I2C device. And basically I create a buffer here called 10.255. If you remember in the I2C test, you'll remember whenever I was sending commands to turn the relay on, I was sending 0x0a. The decimal version of that, which 0x0a is a hexadecimal byte. The decimal version of that is just 10. And then I was passing FF, which converts to 255. I could pass 0x0a here if I wanted to. I just prefer decimal, so I pass a 10 here. And then basically I make a call to write that byte array called buffer to the I2C device, and I specify the length and of course the file, which is passed to this method right here. And then I say, if write return does not equal 2, which was the expected bytes back, then something went wrong, and I close the C library and I return false. Else, if everything went good, I return true. Basically the same thing down here for this turn off all relays method I have. Pass it a file. Only difference is I'm passing it a 0 here to turn all the relays off, whereas I'm just sending 255 up here. And pretty much same thing. If it doesn't return 2, then something went wrong and I return false, else I return true. So without further ado, up here we will create our little while loop. I'll say while true. So this is basically just an infinite loop until I call it to break. I'll say if turn on all relays. I pass it the file that we created earlier. Oops. If I can write. So basically this right here is going to call this method to turn on all the relays, and it's hopefully going to return true, and then I'll land here. Else it's going to return false, so I'll say else break, because something went wrong. So I want to break this while loop, and then once I get outside this while loop, I'm going to say return to basically stop the program. Okay. So inside here I'll say well, if that went well, then I have to have a try here. I'll go ahead and just write in I'm going to wait basically a tenth of a second before turning off the relays. So I'm going to basically infinitely turn the relays on, wait a tenth of a second, turn the relays off, wait a tenth of a second, turn the relays on, in an infinite loop. So I'll say thread.sleep. We'll pass that 100, which is 100 milliseconds or a tenth of a second, and it's going to tell me I need a try catch. So I'm just going to click surround with try catch here. Okay, so after the sleep, I guess if I do get an exception on sleep for some reason, I would want to break right there, which highly unlikely. I've never had a sleep method break. But basically after I sleep, I want to say if turn off all relays file, then I want to say thread.sleep 100 milliseconds. Else, if something goes wrong turning off the relays, I want to break. So hopefully what happens is we land here, we say turn off all relays, that works. We land here, we wait a tenth of a second, then we turn off all the relays. If that works, sleep a tenth of a second, and then back to the top. Turn on, turn off, turn on, turn off. And if anything goes wrong, we've got if-else statements in here to break this while loop. And basically after the while loop breaks, we return to kill the program. So that is essentially it for our little demo program here. We've got these methods to turn on and off the relays. We create a public interface of the C library, which overrides these methods: IOCTL, open, close, read, and write. And basically this may look like a bunch of gibberish, it may not, you may understand it, but basically just know that this is what we have to call to make all this work. And that's pretty much it. So at this point we are ready to save this this program. You can just hit Control Save on Windows or Command Save on a Mac. We'll save it. We need to make sure and let Eclipse know which method or which class is contains this public static void main method. So the way that we need to do that is go up here to your root directory, right click, and then go to Run As, Run Configurations, and then you want to go here to Main up here at the top, and it should say this here. If it doesn't, you can click Search. And I actually had mine set to native by accident, which caused a failure. So you want to make sure and select this class right here that you created and click OK. And then you'll want to click Apply. So we can close that, and now what we're going to do is we're going to right click, go to Export, Runnable jar file, and then we'll click Next. You want to make sure in your launch configuration that you've got that set there, and then you'll want to have a export destination, which I have a folder in my documents folder called BeagleBone jars, and that's where I'm putting it at. You'll need to put in a name for this BeagleBone jar. I put in bbb_I2C.jar here. So and then we'll want to make sure and select package required libraries into generated jar, which basically means take this JNA jar and package it into this runnable jar. So that's very important right there. And then we'll click Finish. And it's saying that it already exists because I've already exported, so I have to click Yes there. Okay, and it should go off without a hitch. So now what we need to do is we need to open up our FTP client. Like I said, I'm using FileZilla. You can use any client you want, but I highly recommend FileZilla. You'll want to make sure you're connected to your BeagleBone. And then where we want to go is we want to go into, from the root directory, we want to go into User, and then we want to go to Lib, and then CGI-bin, and this is where we're going to upload our file to. So I'm going to just drag this file over, and it's asking me to overwrite because I already had it there. So say OK. Okay, and now you can see the permissions on this file is RW. So root has permissions to read and write. So now we've got that uploaded, we're actually ready to run that file from the terminal. So SSH into your BeagleBone, and what we need to do is we need to type in java-jar, letting it know we want to run a jar file, and then give it the directory of your, or the path to your jar file you just uploaded, which is /user/lib/cgi-bin/BeagleBone Black, and always remember you can hit tab to just complete the file name and hit enter. And hopefully at this point whatever you were doing is working. My relays are flashing on and off on my board, so I know that everything's pretty much good to go. So from here, you know, we can what we want to do is hold down Control and press C to stop that runnable jar. I can perform the last task that I performed in the terminal by simply pushing the up arrow on my keyboard, and that'll bring up java-jar, and we can hit enter and run it again, and your jar should start running again. So we'll hit Control-C to stop it. So basically that is how you use Java with the JNA library on a BeagleBone Black to control I2C devices. So from here, what I would do is go back into my Eclipse project. Now that I know that everything's working correctly, I could go in here and maybe add some more stuff, basically I could say here, if this works, and I want to say system.out.println, I could say all relays on, okay? And then I could come down here to turn all relays off, and before I return true, I could say system.out.println all relays off. Okay, and then oops, I need to put that inside those parentheses. Okay, and then we'll just hit Command Save or Control S or Command S to save our file. Go back up here, right click here, click Export, Runnable jar. Since we've already exported it once, everything should be all filled in for us here. We'll click Finish. It's going to give us a warning if we want to overwrite. We'll say yes. Then we can go back into FileZilla. Go back into our lib CGI bin, and basically what we'll do is we'll just drag our modified file over here, and it may give you a warning to overwrite, and you'll just say yes, allow it to overwrite. And now it's uploaded to BeagleBone. We open up our terminal, we hit the up button to run our command or our program again, we hit enter. And now you'll see mine's turning the relays on and off, but it's also printing out here on the terminal all relays on, all relays off. And you can see how fast that is. If you didn't put delays in there, it would be really fast. I2C is a super high-speed communication protocol. So I'm going to hit Control-C to stop it. So that's pretty much it. This is what you're going to do. You're going to go into Eclipse. You're going to make changes. You're going to export the runnable file, upload it to the BeagleBone, and then run it from the terminal. Which this is all well and good. This is fun to play with. And for some embedded applications where you just need the BeagleBone to power up and maybe read the status of some devices and then send that data to another remote server or something like that, this is perfect. What you could do on your BeagleBone is you could actually go into your RC local. We could say change directory /etc, and then we'll say ls. And you'll see this this file here called RC local, which is where we set the permissions on that I2C bus. Very important. We'll say sudo pico rc.local password, and yeah, remember we entered the chmod 777 for this I2C bus, because if you don't do that, every time you restart that I2C bus, won't have permissions for you to write to it. But here, if you wanted to, after that line, you could actually run your application from here. You could say java-jar /user/lib/cgi-bin /BeagleBone Black, what was it, underscore I2C, I think it was. Yeah, so you could write that in there, and then basically as soon as your BeagleBone Black boots up, it'll execute that Java application. So that Java application could sit there and just receive, maybe listen for a TCP socket, and whenever it receives particular commands, it could turn relays on, read the status of inputs and reply back to the client connected to it. It could just monitor inputs and then send out a UDP broadcast if an input's tripped. It could monitor inputs and then send an email. And you can pretty much do all this without a graphical user interface if you wanted to. Embedded applications like that don't really particularly need a user interface. You can do all your file manipulation through the terminal here. If you do want to have a GUI or a graphical user interface, that's what the next article in this or the next segment in this article is going to be on. It's going to be basically using Tomcat 7 to deploy WAR files that will interface to your Java application so you can get on there and turn relays on and off. So that's pretty much it for this here. I know this is a lot to take in. You may need to watch this video a few times, and like I said, I'm going to post all this code on this page so that you can just download these projects if you don't want to manually write it. And of course there's going to be a written list of steps on this article as well. So that's pretty much it for this. I hope you learned a lot. I hope this is going to be helpful for you guys. If you have any questions, be sure and let us know. My email is travis@controlanything.com, and I'm always more than happy to help. So I will see you in the next article, and good coding.